Hi, so let's start with a new topic today, that is embedded coding. So I hope I have explained previously the point functions and pointers in these are all clear. So today we will be focusing on embedded coding. So today I will be going through the board overview and doing a short programming like embedded blinking. So today main focus will be how we can start coding on the board. Okay, what all steps we have to follow, or what is the basic requirement to start code from the scratch, from very basic. If you don't know how to how the code is actually being burned, so that all points will be clarified in this video. So let's start. Okay, so this is the board which we will be going to use for demonstrating all the concept of embedded coding. And now let's look into some of the main features of this board. So first, to work on this board you need to know that this board has a schematic. So what does it means? Let's first look into that. Okay, now you can see the same board in the camera, and this is the schema. This is actually the close look for the board. So there is this blue button, that is user can control this button, like you can manipulate or you can assign this button to do any work. Then you have this black color button, that is this button here, this one. This is the reset button. So what is done, when you press this button, the code will again restart from the main programming. Wherever is the code currently, it will stop from there and it will restart from the beginning, that is from the main. Okay, and as I already told, this is the user control button. Now in this board we have two things. One is, this is the main MCU. Okay, and this MCU used for debugging. Okay, and this section, like this section, which is divided, like here you can see it is divided. So this section is called the debugger section. This is the debugger. So what does debugger means? Debugger means whatever code you will be running on this MCU, you can check the continuous execution of this code. You can monitor some variables value in using this debugger. Without this debugger, it is very you cannot flash the program into the IC. Like this debugger only enables you to connect to this IC and flash the program into it, and plus you can also monitor the program through this debugger. Okay, so for starting, this is the basic things. And now how you will know which pin is connected to which pin of this IC, right? For that we need some kind of schematic. Like for example, here you can see 3.3 volt. Here also there we you can see that there is 3.3 volt written here. Here in this location it is 3.3 volt is written. So if we want to know exactly which pin is giving 3.3 volt, then we should have a schematic layout of this. Or you can say that there is SPI I2C, like this is I2C. Then there will be SPI, this is mesomosi, these are SPI. So when we want to have to know the exact location of the pin, so which pin we want to use from this IC and which pin is connected to here, then we need to have some kind of schematic that will give us that reference, right? So that is called the schematic. Schematic is nothing but it's the IC has multiple pins. So we need to know which pin is connected to which point. Like this point, from this point I mean to say this pin, this which pin is connected to which pin of the IC. So this is schematic. Schematic is a drawing that will give you the connection diagram. And we need a reference manual. So as I told you, working with embedded is more about knowing how to work. Okay, so you need to know how this IC will actually work. You if you have a SPI or a UART or and I2C. These are actually the protocols that will be supported in this board. Then you need to know what all things are supported in this SPI. So how you can use the SPI, then how you can configure the SPI. So similarly, how you can use UART, configure UART, get data from UART, write to UART, what all interrupts available in UART. So these all details are available in the reference manual. Okay, so let's see first the schematic part. How does a schematic of a board looks, then we will look into the reference manual. So this is actually the schematic diagram of the board. So you can see the like this kind of PDF will be available which will give you the schematic of the board. So if you closely look, So these are the markings for the board to understand. This is the first keyhole, second keyhole, like that these have. And then you have here this names like this header connectors, like this one CN10, or then you have this female connector name CN9, CN5. So if you see closely here also, it is written CN9, CN10, like that. So you know which pin you are focusing on, and you can work on that pin. So in that manner, you need to know, okay, this is CN10 number 2 and it is connected to PC8. Now this PC8 is actually the pin on the IC. This is the main IC. This one is the main IC, and on this the pin PC10 you need to find. This is PC10. So finally this PC10 is connected to this one, that is CN10. This PC8 is connected to CN10 off. So PC8 you will get here. So where is PC8? You have to find. So this PC8, this is actually the pin marking of the MCU, and the same pin is available on the board at this location, at the CN10 location. So you can use this pin to do the external connections. Okay. Okay, now let's look into the reference manual part. So this is actually the reference manual for STM F401 ICs which I am using. So what we get actually from the reference manual. In the reference manual, we get all the detail of all the functionalities that are available with this microcontroller. So if you look into the bookmarks, then you can see it has general purpose GPIOs, that we call GPIOs. Then you get the clock related thing. Then you can look into the memory architecture of this GPIO. You can see how the memory is mapped. So if I went go here, then these are the memory map from where to where, what is its use. So like that you get all the details. Now let's take one example to understand it. Like let me say, like you want to use one pin of this microcontroller to control an LED, just to flash an LED. That we will be doing in this video. Okay. So now you know there is general purpose GPIO. So you went into GPIO section, and here what it says, you need to read that there each general purpose GPIO has four 32-bit configuration register. So it has configuration register, that is GPIO mod DR. So mode you can adjust. So now let's look into main features of GPIOs. So what are the main features of GPIOs? Up to 16 IO under control. So you have 16 pin IOs under control. So output, to make the LED glow up or down, you need to have it configured as an output state. So the output state support push pull, open drain, and pull up pull down configuration. So all these configurations are mentioned in this main features. Now these will show how actually the GPIOs will be working, pull up register, where we will be connecting the pin, what all protections are available for the GPIO. Everything in detail is available in this reference manual. Now our main concern will always be with the main registers that are available with the GPIO. So first of all, MODR register. So MODR is the mode register, where we can set the mode of the pin, like how you want to utilize the pin. So here you see here, like these bits are written by software to configure the IO direction mode. So it will set the direction of the mode, whether it is an input or a general purpose output, or alternate function mode, or analog mode. So what is meant by input? Input means this pin you can use to check or capture some incoming signal. That is the input mode. Whether you are giving high to the pin or low to the pin, you can use an input. Then general purpose output mode. What is output mode? You want to turn on an LED, so you want to give some voltage out from that IC, so that mode you can configure. Then there is alternate function mode. What is alternate function mode? The same GPIO can be used by some communication protocol lines like UART, I2C. For that purpose also, that pin can be used. So that is an alternate function. And then there is analog mode. So what is analog mode? To measure how much is the voltage or current, we use analog mode. For that purpose only this analog mode exists. Now the next thing is the GPIO port out type register, O type register. So let's read this, what it is. So it is saying that uh, these beads are written by software to configure the output type of IO port. Now if you are configuring the pin as an output, then you can configure it as output push pull, output open drain. So these are the different configuration of the output available. Either it will be a push pull type or it will be an open drain type. Okay. Now there are other things like port output, speed register. So you can go through one by one what it is. Then there is pull up pull down configuration for the for the pin. So for everything there is a particular register. At that particular register you need to write either 0 or 1 to make the configuration for that pin. So I hope you have some got some idea like how the output will work. It is basically you need to configure the pin, and then you just need to turn on and off that particular resistor that will make the pin high or low in case of an output. And in reverse, if you want to read something, then you have see this input data register, which you can read and get the sorry, input status register will be there. So which you can read and get the means what is the current value of that pin. Okay. So like this we can configure an input output. So let's look into the code part and understand it. Okay, so I will be using CubeMX IDE for doing this project. So as I am using the controller and evaluation board from ST, so I will be using this one. So let me show you how you can create a project. So you have to create an STM32 project. Now, if you have a evaluation board from ST, then you can directly put the commercial part number here. So you can find it on the Nucleo board, commercial part number. So it is, so this is the board. This is the Nucleo board which I am using. Then you have to press next. You have to give the project name. Okay, now here you need to understand that the firmware package which it will be using is this one, version 1.28, and we will be copying all the necessary files and library from this version or for this version. Okay, now press finish. Now this is asking to initialize the peripheral as per the board connection, as it is already a pre-connected boards and it has the onboard LEDs and the buttons connected. Okay, so I will select yes. Okay, now the entire configuration is complete. Here you can see it has copied all the driver related file, and also it has created a basic layout of the project using this controller. Okay, and here I will show you we have already the pins has been assigned, like B1 is the blue push button that is available on the board. There are two, there is this UART pin which is configured by this, and we have one LED that is the green LED which is already configured. Now let's see how this LED we can make use of the code and may blink the LED. Okay, so let's go to the main file, main.c file. So just to give an overview, include contains all .h file where the declaration of the functions will be, and source file contains all the logic related function in it. Okay, so the first code which we are going to see in main.c is how the GPIO is getting initialized. Now, one more important thing, like I told you, right, that GPIOs are basically the pinouts. So here you see how it is. See here. So LED, green LED is connected to this PA5. Now this PA5, if you go to the schematic diagram, then you have to search the PA5. So if I search PA5, here PA5. Okay, now see, this is the pin related to PA5. This is here, the PA5 is connected here. Now, if I go to the next board, so PA5 is present here. See here, PA5 is being present here and it is connected to CN5 connector number 6. Like that, you can get the pinouts of this microcontroller on this board. So what I am doing is, this is the microcontroller. Okay, these pinouts are connected here and here. Okay, so this you can find it out from the layout of schematic diagram of this board. Okay, so now PA5 is there. This is the green LED is connected. Now we go to the main.h file first. So in main.h you see the label. There are two things, one is the label, one is the actual pin address. So you see this is the label given, that is the led pin. So led pin is pin number 5 and GPIO A. So how this is known, everything that starts with a pin is represented as a P, and since it is GPIO A, so it is PA and pin number is 5, that's why it is PA5. So PA5 is pin number 5 and GPIO A. Now if we go here to this GPIO pin, you will see that this actually is a macro, and if you go to the base address, in the base address the starting address of the GPIOs will be defined. So this will be the addresses where this will be the actual register address that we need to configure. So we don't need to take so much of trouble. The CubeMX will be defining this base address for the GPIOs. Now if we go to main, so this has been mapped for, it's just that we don't need to remember the pin number and the GPIO set number. So we, for our own ease, we have defined led pin and led2 GPIO port number. Now to blink that led, we have some hal functions available. So first thing, what are hal functions? So hal functions are basically those functions which help you to connect your code to the actual hardware layer. So hal is the hardware abstraction layer. So first thing is, we know that whenever the code start, it will start from the main function. The pointer will come at the main stack pointer and it will start execution from the main. So now first thing you see, we are configuring the hal.init. We are initializing all the hal related functionality. So all the addresses related to that pin will be mapped in this function, because hal APIs will be common. When you change the APIs, the same hal layer will be mapped to different addresses. Okay. Now then, system clock configuration. For any board to function, it needs a clock frequency, so clock will be configured. Then GPIO init. So this is very important, like the pins which we will be using, they are called general purpose input output. So this GPIO should be initialized. Now let's see what it will do in GPIO init. So if you press Control and click, it will take you to that GPIO init pin, that function. So in GPIO init, so you see that what it is doing, it is first enabling all the clocks related to the GPIOs. So we have GPIO A, B, C, and H. So these all clocks will be enabled. So GPIO functionality can be started. Then we are only configuring the GPIO related to pin, that one push button and one LED. So for a push button, this is the blue pin that is configuring the push button, and then there is this LED pin that we will be using. So this LED pin, how we are configuring, first we are passing the pin which we want to configure. So this LED pin 2 is actually this address we are passing to this structure. Then we are putting the mode, what it is, it is output type push pull. So this value we will be passing to the mode register. And what is the pull up register value, we are giving no pull ups. So for that we have specific value that we are passing to the pull up. And the last thing is speed, what speed you want this pin to be. So for us it is a low frequency, we don't want to toggle this pin at very high, so we are giving a low frequency. And then we are calling the GPIO init function. So this init function will initialize that pin with this specific configuration that we are passing for that pin. Remember that this configuration is particular to that pin for the port A. Okay. now now here we are configuring another pin as an input. This is configured as an output, now we are configuring as an input. So in the input also we are passing the pin number which we are configuring as an input. Then we are passing what will be the mode. So here you see it is saying GPIO mode IT falling edge. So it is saying that the button should be configured into falling edge IT, that is interrupt mode. In interrupt it should capture the interrupt whenever there is a falling edge. Okay. And what is the GPIO push pull type? No pull, means there is no pull up register connected. And finally we are calling the GPIO init. So just remember, we need to give the pin which we want to configure, the mode with which the pin should be configured, and the pull up register which we want to use. If it is a input, then there is no point of giving the speed. we only want to give pin mode and pull-ups. Okay, and we configure it. Okay, now when now this function is called here, so GPIO gets configured to that particular form. Now again, one more thing is that we want to toggle that input. So how we can do that? Let's see. We have HAL layers. We have the HAL APIs. So we call the HAL APIs. So HAL underscore, and if you press Control and space bar, then it will give you some suggestions. So we have to do HAL GPIO. Then what we want to do? We want to toggle the pin. Okay. So if we say toggle means one time toggling means it will be on off, right? If it is on, it will off. If it is off, it will become on. So here it is saying pass the GPIO value, the particular pin register value we need to pass. So first is the port number. The port number is GPIO A. And what is the pin number? We know the pin number, it's 5. So we can pass GPIO underscore pin underscore pin number 5. We are not using any hash defined methods like a blue pin or white pin. We are just giving the actual pin value GPIO A and GPIO pin number 5. So this symbolizes PA5. So just remember here, A means GPIO A and 5 means pin 5. Okay, and now let's give a delay. What is a delay? Like after a delay only this loop will continue. So we give a delay of HAL delay, and we need to pass a 32-bit, and HAL delay works with in milliseconds. So we give a 500 millisecond delay. So this is 0.5 second delay. Okay, and we save and build the code using this one. Okay, so you can see the code is getting built. So here the code build is done. And now one more thing, whenever you build, if it is in debug mode, so it will do the debug build, and all the debug build related things will be present here. Okay, and here you can see what is the total size of your program, how much data there is, what is the how much RAM it will use based on this BSS and data. So this much amount of RAM will be used. This, how much is your code size, this is the size of the code, these all are in bytes. So this much will be the size of the program. And now let's connect the board. Okay, I'm connecting the board using the USB cable. You can see the debugger has turned on, and the board also got power. So there are some pin configuration using which you can use this debugger separately also, or you can connect it to this board. So now what I will be doing, I will be flashing the program using this debugger. So when you want to flash, you have to select the blinking LED project, then click on debugger. For first time you have to do this debugger configuration. Select ST-Link, scan it. So there are two options, SWD, that is serial wire debugger, or JTAG. So we are using SWD, and click apply and OK. So now the debugging is on, and I am going into debug mode. So finally the debugging is on, and I will start it. So you can see the LED has started blinking. So if I make it stop, pause the, then LED will be paused, and if I start again, the LED will start blinking. So this is how you can make the LED blink. So I hope you understand what is happening. Okay, now let's see what is actually happening inside this function to have a clarity what it actually is doing. So if you go inside the function, you see here we are passing this entire GPIO A value. So this will be mapped to a structure. In that structure, we are taking this GPIO A referring to the ODR register, that is output data register, and we are selecting the BSRR, that is the input output, that where we can set and reset. So what we are doing, if it is set, we are resetting it, so we can monitor it. Let me just type here GPIO A, and if we open it, you can see here in the ODR register it is getting updated. and in idr register the last value is getting changed, one value is getting 0101. So now we can write one more simple logic in this. Let's stop the debugging. Okay, and let's write a function that we only want it to toggle whenever we are pressing this blue button. Okay, so what we need to do, we need to write an if statement. If all underscore GPIO, then read pin, there is a read pin, so which is connected to which pin is blue pin. So here you can see this is PC13, so I can directly use GPIOC and pin number 13 for reading it. So in order to confirm it, you can go to .h file and you can see this is pin number, let's see, button, yeah, this is GPIOC and pin number 13, right? So I can go here and write GPIOC and pin number 13. Now there is a catch, these pins are by default high. Okay, these are by default high, so we need to read only by default low. So if you okay, fine, we check first this whether it is high or low using this functionality only. So if it is high, then we will be toggling the pin. If it is low, then we will not be toggling this pin, right? So let's build it and flash it. Okay, and run it. So now you see this is getting, this is blinking. Now if I press it, you see it will stop blinking, it will be in the last state where it is, because this pin by default is high. So this pin is by default high, if I press it, it becomes low, and at the time whatever is the condition of the pin, last condition will be in hold. So now the last condition is off, so it is in hold. Okay, so I hope this, in this tutorial you understood how we are utilizing the GPIOs. And in this read function also, let's go and look what is happening. So in read function, when we are reading, so it is checking the IDR status, that is input data register status of that pin, and if that is low, then it is passing low, or if that is high, it is passing high. So what it is passing, it is passing 0 and 1. For set it is passing 1, and for reset it is passing 0. Okay. Okay, so I hope this embedded coding part, like board schematic, how to look into board schematic and the LED blinking program, where I explained about the GPIO and the hall layer, how it is being used, is clear. So in the next videos, we will be looking into UART communication and the interrupt handling part. Okay, so I hope if you like the video, please like, share, and subscribe my channel. And thank you.